are now joining, right? Okay. So in the previous class, what we have discussed, have you remembered? Okay. Is my slides are visible? Okay. So we were discussing about the normalization, right? So normalization, you know, that is the process or methods of organizing our data in our database, right? So, or reduce the redundancy or reduce the anomalies like insert, update, and deletion anomalies. So the types of normal forms we were discussing, there are 6 normal forms generally listed. So we have discussed about the first normal form, second normal form, third today we'll start, and this all will start today. So first normal form is regarding like in the if the table is in the first normal form, there should not be any that values should not be multiple values cannot be allowed actually. So if the values are atomic, then the table is in first normal form. So in second normal form, there should not be any partial dependency, right? So now this third normal form, we'll come to the third normal form. Okay, first normal form was there, that is already discussed. So third normal form, in the third normal form, the table must be in the second normal form. If we say the relation is in third normal form, 3 and f, then it must be first, second normal form. And it should not contain any transitive dependency. I think my voice is echoing. Is it?
Yes, ma'am, the voice echoing.
When I'm hearing that, it's so I don't know why. Is it echoing still? Still, it is echoing. Okay.
No, it's fine.
Okay. Now it is fine.
Yes, ma'am.
Okay. So in third normal form, what we have to do? We have to reduce the transitive dependency, right? It should not contain any transitive dependency. Transitive dependency, you know, I think, right? You say x derives y and y derives z, then x can again derive or determine z like that, right? So if there is no transitive dependency for for non-prime attributes, then the relation must be in the third normal form. That means that non-prime attributes. Prime attributes, you know, the prime attributes means that attributes are the set of candidate key that are member of the candidate key, right? So candidate key already I think we have discussed. You know that candidate key. What is candidate key? The minimal super key actually. So you know the super key. Super key means by closure of that set of attributes, we can find out all the attributes of the relation. That is the super key. And if the super key, that is the proper subset cannot determine the all the attributes. That means minimal that super key is the candidate key actually, right? So we'll discuss that also later. So here non-prime attributes are prime attributes are the member of the candidate key. Say if A B, say, for example, here it's like if A B, this is our candidate key, then A and B are, so we are one relation A B C D. This is our relation. So in this, if we are having A B candidate key, then A and B, these are prime key, and C D, which are not in the prime key, sorry, not in the candidate key, that are non-prime key actually. Understood? So that prime key and non-prime key is that one. So here, what is that? Non-prime attributes are there. Then the relation must be in the third normal form. So here we are having, say, one relation, that relation is in third normal form. It holds at least one of the following rules. Like here, so we are having the functional dependency x determines y. Then x determine y. Then what will happen? X should be a super key, right? And y is a prime attribute. So left hand side, that that attribute should be super key, and the right hand side, that y, that should be in prime attribute. That attribute should be in the prime attribute, right? That means prime attribute means that each element of the y is a part of some candidate k. That means here, say, left, that right hand side, that should be in the is a part of the candidate key. So we know the candidate key, right? Okay, well, here we have one example. So here super key in this table, we are having employee ID, employee name, employee zip, that is, and employee state, employee city. This is our table. So here super key in this table is like employee ID, employee ID, employee name, employee ID, employee name. This all, that means from employee ID we can determine all this. These are non-prime attribute, right? So here candidate key is employee ID. That means employee ID can determine all the other attributes, right? All other these attributes. So here candidate key is the, sorry, employee ID is the candidate key. So non-prime attributes are, here prime attribute is employee ID, and non-prime attributes are that other attributes like employee name, employee zip, employee state, employee city. These are non-prime attributes, right? So now see, in our that table, employee state and employee city depends on the employee zip. So you can go back there. Employee, and this one, employee zip, employee state, this depends on employee ID, right? And this one again depends on, you see, employee zip again depends on employee ID. So city and state, it is depends on the like zip, the employee city and employee state. This depends on the zip, this pin number, right? So if it is depends on that, and again this employee zip is depends on the employee ID. Say this employee is having this zip number, that means they are from UP and Noida. UP and Noida. Say these states and cities are determined by this employee zip with zip number, right? And this zip number again, how we are finding, that is determined by employee ID. That means this employee ID belongs to this zip ID, zip number. That means employee zip. That means we can find out this is the state and the city, right, from the zip. Okay. So and that non-prime attributes are employee state and employee city, and super key is employee ID, right? So now, so it is violates the rules of third normal form. So in the third normal form, there should not be transitive dependency, right? So here, but we are having that. So employee state and employee city depends on employee zip. Again, employee zip depends on employee ID. That means this, so we can derive from this that non-prime attributes employee state and employee city transitively depends on super key employee ID. Understood? So this is violating that hard normal form. That means transitive dependency is there. So this table is not in the third normal form. This is 3 and F. So now if we like separate the table into like tables, like employee zip table and another one is employee table, right? So how it will be like employee state table and employee city, that will come to another one table. See, we have this one employee table and one employee zip. So in employee table, we are having employee ID, employee name, and the employee zip number. From the zip number, we can find out the state and city, right? So in this table, employee zip, see here, the zip, employee zip is the primary key here. So from the primary keys, the state and city we can find out, right? So here now in this two table, there is no transitive dependency, right? Say, but in the previous table, the transitive dependency was there. But here, see employee ID, we are just this employee zip we can determine, right? Say employee ID determine the employee zip, and this employee zip it is in another one table. So by finding this, we can go there and see okay which one, right? But in the same table, it is not there, right? So that is the third normal form 3NF. In 3NF, we should reduce remove the transitive dependency, right? So first normal form, the values should be atomic. In that second normal form, the partial dependency should not be there. And the third normal form, transitive dependency should not be there. That means we should remove the transitive dependency. Then now, next one is Boyce code normal form, BCNF, which is called BCNF. So this is the advanced version of third normal form or 3NF, we can say. So here, that means and the table is relation is in third normal form means by default it is in the first and second, and BCNF means by default it should be in the third normal form, right? And another one here, the rule is the left hand side should be is the super key. Left hand side, that means the determinant attribute should be the super key. Understood? So in Boyce code normal form, that means BCNF, we should like find out whether the determinant attribute is super key or not, right? So that means say we are having x, the functional dependency x determine y. X is the super key of the table. That means and this x, that means left hand side that attribute should be super key. Understood? So let's say we have one. Here we have one table: employee ID, employee country, department type, and department number is there. Okay, you can see here that functional dependencies, what kind of functional dependencies may be there. So employee ID, maybe employee country, you can determine employee country. From the employee department, you can determine the employee type and employee department number, right? So candidate key is here, employee ID and employee department. So now from employee ID and employee department, you can like determine all other attributes, whatever in the table is, right? These all tables you can find out. That will go with one example in later. So here, so the table is not in the BCNF because neither employee department nor employee ID alone are super key. See, this is separately. It is not the super key. For that, it must be super key because employee ID is not determining all other. See, for super key, say if employee ID can determine all other like this all like other attributes, then it will be a super key. But alone this employee ID is not a super key. Or alone this employee department number, it is alone cannot be a super key. Because if we get the employee department number, only we'll get these two, like department designing and type. We cannot get the country and the employee ID. But if we get this, say employee ID, we are having this. Without this, we cannot find out what type of in which department is belongs to, or like if we don't have this one. But both together, we can. If both together, employee ID and employee department number is a super key, then if they both are in one like set of attribute, then we can find out from there these all attributes, right? Employee ID again, and employee country, and employee department, employee type, and employee department number. So here you can see candidate key is the employee ID and employee department. So now that table is not in the BCNF. So to convert it into BCNF, what we have to do? So we have separated that. Huh?
আকৌ পৰা ৰিপিট কৰি দিবচোন, বুজি পোৱা নাই ভালকে।
কোনটো ৰিপিট কৰিব লাগে, BCNF নে থাৰ্ড NF?
BCNF।
BCNF টো হ'বলে তোমালোকক ফাৰ্ষ্টতে কি হ'ব লাগিব, থাৰ্ড NF টো হ'বই লাগিব, 3NF টো হ'বই লাগিব, আৰু কি হ'ব লেফ্ট হেণ্ড ছাইডৰ আমাৰ যিটো ফাংচনেল ডিপেণ্ডেঞ্চি দিয়া থাকিব তাৰ লেফ্ট হেণ্ড ছাইড তাৰমানে ডিটাৰমিনেণ্ট এট্ৰিবিউটটো তোমাৰ ছুপাৰ কি হ'ব লাগিব। ছুপাৰ কি হয় এইটোতো গম পাইছা, ছুপাৰ কি হয়? ছুপাৰ কি মানে তোমাৰ যিটো কি দ্বাৰা আমি বাকী এট্ৰিবিউট গোটেইখিনি এট্ৰিবিউট আমাৰ ৰিলেশ্যনত থকা গোটেইখিনি এট্ৰিবিউট আমি ডিটাৰমাইন কৰিব পাৰোঁ। বুজি পাইছা? চ' ইন দিছ টেবল চে হিয়াৰ আমাৰ যদি অকল এমপ্লয়ী আইডি এটা আমাক দিয়া থাকে, অকল এমপ্লয়ী আইডিটি ল'লোঁ, কিন্তু যদি ডিপাৰ্টমেণ্ট নাম্বাৰটো বা ডিপাৰ্টমেণ্টটো আমাক দিয়া নাথাকে, তেতিয়া আমি এইখিনি গম নাপাম ন, টাইপ বা হেৰি। এতিয়া এমপ্লয়ী আইডি এইটোৰো হ'ব পাৰে, এইটোৰো হ'ব পাৰে, 264 this employee ID, this employee 264, he might be in designing or testing. He may work into a department, right? But
Yes, ma'am.
কেনেকুৱা টাইপৰ হয় কি হয় সেইখিনি আমি নাপাম যদি আমি এইটো বস্তু নাপাওঁ, মানে এইটো ডিপাৰ্টমেণ্ট নং বা ডিপাৰ্টমেণ্ট যিটো আমাৰ প্ৰাইমেৰী কি ইয়াত মানে অকল এইটোৱে এইখিনি ডিটাৰমাইন কৰিব নোৱাৰে, বা অকল ডিপাৰ্টমেণ্ট নাম্বাৰটো দিলে বা এইটো ডিজাইনিং দিলে, টেষ্টিং কিবা, ইয়াৰ পৰা আমি কোনজন এমপ্লয়ী কোনটো আছে ইয়াত ধৰিব নোৱাৰিম। মানে ছুপাৰ কি হ'বলৈ হ'লে আমাক এমপ্লয়ী আইডি আৰু এমপ্লয়ী ডিপাৰ্টমেণ্ট বা এমপ্লয়ী এইটো কোনোবা এটা লাগিব ন, এই দুইটা একেলগে মানে তোমাৰ যদি থাকে তেতিয়া সেইটো ছুপাৰ কি হ'ব। গোটেইখিনি তোমাৰ কি কৰিছে ডিটাৰমাইন কৰিব পাৰিছে হয় নাই, সেইটো ছুপাৰ কি হ'ব। কেণ্ডিডেট কিটো মিনিমেল যিটো ছুপাৰ কি হয় মানে গোটেইখিনি হেৰি কৰিবৰ কাৰণে প্ৰপাৰ ছাবছেটটো যদি মানে ছুপাৰ কি নহয় তেতিয়া সেইটো কেণ্ডিডেট কি হৈ যায়। বুজি পাইছানে কেণ্ডিডেট কি আৰু ছুপাৰ কিৰ মাজত ডিফাৰেঞ্চটো? নাই বুজা?
অলপ বুজি পাইছোঁ মেম।
অলপ বুজি পাইছা। এটা এক্সাম্পল ল'লে তোমালোকে চাগে বুজি পাবা। 1 second. So here, so we are having one relation, this one A, B, C, D. ঠিক আছে, ইয়াত যদি আমাৰ ফাংচনেল ডিপেণ্ডেঞ্চি দিয়া আছে যেনিবা A derives A determine B or say C D কিবা এনেকা দিয়া আছে, আৰু এটা দিয়া আছে যেনিবা B determine C হ'ল। এইটো আমাৰ ফাংচনেল ডিপেণ্ডেঞ্চি তলত যিটো দিয়া আছে সেইটো আমাৰ ফাংচনেল ডিপেণ্ডেঞ্চি, এইটো আমাৰ ৰিলেশ্যন। এতিয়া ফাৰ্ষ্টতে ছুপাৰ কি আমি কেনেকৈ ফাইণ্ড আউট কৰিম, তোমাৰ এইটো চোৱা। চ' ইয়াৰ ৰিলেশ্যনৰ পৰা আমি ফাৰ্ষ্টতে কি ক্লজাৰটো উলিয়াব লাগিব। ক্লজাৰটো কেনেকৈ উলিয়াম, ফাৰ্ষ্টতে চে এ বি চি ডি, এইটো ক্লজাৰটো যেনিবা আমি উলিয়াই লৈছোঁ। তোমাৰ ক্লজাৰটো ওপৰত যাব, তললৈ অহা নহয় হেৰিটো। চ' ইয়াত কি হ'ব তোমাৰ এইটো A B C D ক্লজাৰ, এইটো এটা ছুপাৰ কি হ'ব তোমাৰ এতিয়া A B C প্লাছ দিছ ইজ ছুপাৰ কি বিকজ দিছ অল ইট উইল determine all the attributes, right? All the attributes in our relation by the reflexive property, right? So here we will have A, B, C, D. গোটেইকেইটা আমি পাব পাৰোঁ। চ' ইয়াৰ পৰা আমি কোনোবা এটা এট্ৰিবিউট কেনচেল কৰিব পাৰি নেকি? By seeing this dependency, whether we can like cut or we can remove any attribute from here. Say A determines D. So that if we are having like D like A, then we definitely can determine D. So that means we can delete, we can remove D. Then also we will find out all other attributes. See here. Next we see A, B, C. C plus. So here we are having this So here again, you see A can determine A itself, right? Then B can determine B itself. See here, B, so B will come here. So C already C is there, so C can determine C itself. So ABC will come anyway. Then now D, whether D can be find out from anywhere. See, A is already there. So if we find out A, then definitely we can find out D. So A is here, so we can find out D, right? So now also it's all that variables came, right? All the attributes came here, A, B, C, D. So that means this is also super key. A, B, C closure. A, B, C is a super key here. First to say we don't know exactly which one we can find out as a super key. So, but like subset of this, proper subset of this can be also a super key. So we are checking it whether A, B, C can be a super key or not. So how we'll check that? So see whether by seeing this functional dependency you can find out whether it can be a super key or not, right? So now A, B, C closure, this can determine all the variables of our table, all this one of this relation. So this is A, B, C closure is a super key. Again, we can see whether here from here we can reduce any variable or not. So see here, if B is C, if we are having B, we can find out C. So here we can remove this one. We can cut that one. That means A, B closure, AB closure, you can determine all the attributes or not, just check it. So A, B is there, that means A and B will come with B. Okay. Then whether C can be determined, because we are having B, from B we can determine C. So C is there. And D, already A is there. So from A we can determine D. So D can be determined, right? So now C. AB is a super key. Here AB is also a super key, ABCE also a super key, ABCD also a super key. So minimal one is ABC. Sorry, AB is a super key, right? From here again you can see whether any A and B, whether we can cut any other attribute A or B, anyone, whether we can reduce more, check it. So if only A is there, say only A, if only A closer, find out A closer, what will come? A closer, it will be in the hub. So A can determine only A and D. B and C will not get. That means it is not a super key, right? So here you see A can determine A itself and A can determine only D. After that we cannot find out any other attribute, right? So this is not a super key. This is not a super key. A closer, A is not a super key, and only B we will check whether only B is a super key or not. B closer, find out the B closer, whether it can be find out the candidate like other attributes, all attributes of the relation or not. So B itself, it will be there. Then B is determining any other attribute. Yes, B is determining C. So C will come. But A and D will not be like determined by B, right? B or C. So this is also not a super key. And here you see B and A. This is not a super key. That means AB, the minimal requirement is AB. So AB is the super candidate key here. See, first candidate key means it is by default a super key. Then if it is the minimal like super key, that means the proper subset cannot determine all the attributes, then it is a candidate key. This is now our candidate key is AB. AB is our candidate key. Understood?
Yes,
This is
ma'am.
okay. Candidate key and super key. That is now. If this is our candidate key, then this A and B is the prime attribute, and other like C, D that are non-prime attribute. So here we are having A, B is our candidate key, and the member or element of candidate key is the member of candidate key that are like prime attributes. Understood? Okay.
Yes.
Now that is our candidate key and super key. That only. So now we are coming to again that slide BCNF. So now to be a BCNF, first it should be in the third on NF, then the 3NF, then the right hand side, that means determinant attribute, that should be super key. So here we have this one in that table we are having that one. So now that table we are going to, this table we are going to divide in 3 tables. Okay. So once employee table, employee zip, 1 to 3rd normal form. Okay. Employee country, then employee department, then employee department mapping. So here 3 tables are there. So now how it is connecting, see, functional dependent employee ID, here employee country determining the employee country, and employee department is determining employee type and employee department now. So candidate keys are here. Another one is left in that next table. Okay. So employee table, first table we are having employee ID, candidate key. In the second table we are having employee department as a candidate key. That means in employee department, this is determining these two, right? All the attributes. And here this both we are needed. This employee ID and employee department both are needed to map both the tables, right? So here the third table, employee ID and employee department. So these are candidate key. That means these are minimal like attributes we need to determine all other attributes. So that is the that super key, which is actually minimal super key. That is our candidate key. So now these tables, these 3 tables are in BCNF. So you can see that left hand side it is super key or not. This is our there's employee ID, employee department, and employee ID and employee. These are now super key. So you can say that this is in BCNF, right? Now we are coming to the 4th NF. Actually, what happens till BCNF only it is important. Generally, in our real in database, we can normalize till BCNF. This 4NF or 5th NF, 6th NF are not that much used actually. So, but still we have to know what is 4th normal form or 5th normal form or 6th normal form, right? But generally it comes till BCNF in practical like practically you can do till BCNF. 4th NF also you can do sometimes, but not that much familiar. So 4th NF is okay. That if the relation is in the 4th NF, that means it should be in BCNF. So the BCNF means the left hand side attribute should be super key. And if it is in BCNF, you should know that it should be in the 3rd normal form. And if it is 3rd normal form means it should be in the 2nd normal form. And if it is in 2nd normal form means it should be in the 1st normal. So now in 4th normal form, it should be in the BCNF. And another one rule is here, properties, it has no multi-valued dependence. Multi-valued dependency should not be there. So say A determines, here we have one dependency, A determine B. If for a single value of A, multiple values of B exist, then the relation will be a multi-valued dependency. Then in that case, it is not in the 4th normal. 4NF, it is not there. So here, say we are having this table, say student ID, course, and hobby. So student ID itself, you can see, you can determine this also, and you can determine from the student ID, you can determine hobby also. But both are like independent, right? So student table we are having, the table is in 3NF, actually BCNF also that is. But the course and hobby are two independent entities. Hence, there is no relationship between course and hobby, right? So, student with student ID and say student 21 contains two courses. So, if he is having two courses like computer and maths, and two hobbies, it is like dancing and singing. Then what will happen? There should be one multi-value dependency on the student ID. So that is actually unnecessarily repeating the data. So what we'll do to make it in four normal form, we can decompose that table into tables like student course and student hobby. In the student course, student ID will be there and student course will be there. Computer, maths, that student can enroll into course like computer also, maths also, like this. And another one table is student's hobby. So student ID, his hobbies may be many, dancing, singing. Like 21 student is having like dancing and singing, and 34 is having dancing like that. So this is hobby table, and this one is course. And here you see the multi-valued is not there. Multi-valued dependency is not only one, right? So now we are coming to the fifth normal form. So in fifth normal form, what will happen? So the relation should be in the fourth normal form, and it not contains any joint dependency, and joint should be lossless. Joint dependency, that union, like joint dependency should not be there. So 5NF is satisfied when all the tables are broken into as many tables as possible in order to avoid the redundancy. But that joining should be lossless. That means we should not miss or we should not lose any values when we are doing that joining, right? So this fifth normal form, that also known as project join normal form. So we are having one table. So here subject, lecturers, and semesters are there. So computer subject can be like taught by different lectures, like ANSIC, like that. And it may belongs to like semester one, same semester also, right? And here, say this maths can be again taught by different lecturer, but it may be in different semester also. So chemistry, like this, see in the first semester, and the faculty name also there. But now here you can see, if say we are having one new semester added and there is no values, then like lecturer is not assigned and subject is not assigned, and we are going to keep it null, but null value is not allowed. That time what will happen is, so that we can, for that purpose, we are going to divide this table in three parts. See how? So semester one, computer, maths, like this, and P2, that table, say lecturers, all the lecturers names are there and which subject they are taking, and the semester and lecture. So this now just separated that tables, right, in three parts. So that is done. Now sixth normal form. In the sixth normal form, anyway, that relation should be in the fifth normal form. Then, and every joint dependency on the relation is trivial. So it should be trivial, right? You can see here we are having student ID, student ID, then student first name, last name, and marks. So actually, sixth normal form is not used. Actually, practically it is not used, but for theory purpose we are using this. See here, we are going to read like separated this one as like student ID, one table like student ID and student first name, student ID and student last name, and student ID and marks. So which is not that much like you can say this in real world, it is not possible, right? So anyway, we need the first name, last name together, and student ID, marks. Maybe we can separate this one, but these two are in the same in real life. If you are in real world, if you are going to do, right? So that's why just we are decomposing the table because it like this way: student first name, last name, and the student results. So student ID is this. Student ID S190, and from the student ID S1 we can find out the student first name and last name, and which is not actually reliable in this real world, right? So now, how to find out the highest normal form in a relation? So to find out the highest normal form, what are the main rules are there, whether it is possible or not? That's what we are going to discuss. See, the steps are to find out the highest normal form in a given relationship, and that means a given relation table. That means, so first you have to find out the candidate, right? Then first you have to find out all the candidate keys and divide all the attributes into two categories, that is prime attributes and non-prime. So you have to find out whether prime attributes, which are prime attributes and which are non-prime. That already we have discussed. Prime attribute means the elements in the candidate key, which are part of the candidate keys, and which are not, that are non-prime attributes, right? And after that, what you have to do, you have to just check it, like whether it is in a first normal form by using their properties, or whether it is in second normal form or not by seeing their properties. Like for second normal form, what is the property? Third normal form, what is the property? Whether that relation functional dependencies are satisfying that properties or not. Based on that, you can find out the highest normal form, like of the relation. Say one example we are having here: find the highest normal form of a relation R A B C D E with functional dependencies. This set is given: A determine D, B determine A, B C determine D, and AC determine BE. So now we'll discuss about this example. Okay. So here you see here. So relation, we are having A, B, C, D, E, and this is our functional dependencies. So here we can see AC closer. See, it is our super key. Whether this is to find out this one, okay, you just by when I have shown you, right, by this one you can find out that. So what was our A B C D, right? A B C D E, A B C D E. So closer plus that is there. So didn't see this plus this is closer. Okay, it should be in the superscript. Okay, now this say first say we don't know whether AC is super key or not, or candidate key. See, we are taking this one as a candidate key, but to find that, first what you have to do, first you take all the attributes here, whatever is there in the relation. So A B C D E we are taking here. See, so now to be a super key, it should determine all the attributes, right, of the relation. So A, B by default, this all will come: A, B, C, D, and E, right? Okay. Now, from here, you see whether we can remove any attribute from A, B, C, D or not. See A, B, C, D, E, whether we can remove any attribute. See, A is determining D, right? That means if we are having A, then no need of D here again. That means we can cut D. So we can cut D, right? And like that, say A, B, C, and E. Now we are having A, B, C, E. Now again you see, okay, just write it again. So D is not there now. So A, B, C, E. This can also determine all A, B, C, D, E, right? So that means this is also super key. So now here you see A, B, C. From this A, B, C, E, whether you can again reduce any attribute or not. Check it. So B is there, A again you are having already, A we are having. So no need. B, C, determines D. Already we have done. And another one thing, A, C determines BE. That means if you are having, so you see, B already we are having, right? And A, B can again determine A. That means B you are having. Now BC determine D. BC again determine D. Already we have removed the D, so no need of this. Then AC determine BE. That means if you are having A and C, you can remove B and E. That means here you see, if you are having A and C, you can remove this 2 also. You can find out this 2 from A and C. Now you just find out whether this can A and C alone can determine all this A, B, C, D, E or not. If it can, then AC is the candidate key. Here closer is there, okay. So now AC closer, A and C will come anyway, A and C. Then whether B can be determined, because AC is there, then B and, you see here, AC we are having, right? AC we are having, that means B and E will come anyway. B and E will come. Then we are having A, B, C, D. A, B, C, D. From A we can see here. D we can determine from BC also, we can determine from A also. That means we are having A means we can determine D. So now you see all the attributes came here, right? A, B, C, D, E. That means AC is the super key here. Now only A or only C, whether A can be determining this all or not. Whether A can determine this all attribute or not. See, only A cannot determine maybe all the attributes. See, only if we are having A means A can determine D, then only D we can determine, right? So D is there, D is not determining anything. So AC, that means AC is there, but it is in the determinant. So we cannot determine BE. We need A and C together, right? But we are having only A. That means A is determining only D. So that means A closer. So A closer is determining only A, comma D. No any other attributes. That means it is not a super key. And you see whether C can be determine any like all the attributes or not. C is determining itself, so it will by default it will come. Then you see again whether C is determining anything, any other attributes. No, right? From C we can get any other attributes or not? We cannot. Only C is not determining BE, right? A, C both is needed, so it is not possible. So C is not determining any other attribute. That means it is also not a super key. That means AC, our AC is our candidate key. So AC, this AC is our candidate key, right? So this is our candidate key. AC is our candidate key. Okay. So now you come here again. So here see, as we have seen that AC is AC, this one see, AC closure is having A, B, C, D, E, but none of its subset can determine all other attributes. That means A closure or C closure, that is not determining, right, all other attributes. Here it is only written. See, this C alone is not determining all the attributes, or A alone is not able to determine all the attributes. So that means only AC can only determine the all attributes. That means AC is our super key. That means candidate key now. See, AC is super key, but it is also candidate key. That means all candidate keys are super key, right? But you cannot say that super key is a that super key may be candidate key or may not be, right? So here AC is our candidate key. Now another one thing, whether any other candidate key is there or not, how you will find out that? So here if C, AC is there, so we are having AC. So AC is determining, say A can be determined from B. So AC, we are having A and C. Now A can be determined by B. That means we can replace A by B, right? So this A, here we are having AC. So this A can be, so here we are having this one, right? So AC is our candidate key. And in this candidate key, say, now we have to see, is there any other candidate key or not? How you will find out that? For that, you have to see whether this A can be like replaced by any other attribute, or C can be replaced by any other attribute or not, and what you are going to get it. So A can be like again derived from B. So that means we can replace A by B. So we can replace A in AC by B. That means we will get BC. So BC will be a candidate key, but you can check it whether it is a BC is a candidate key or not. Let's check it. Say in this example we are having, right, BC. So we have replaced the A by B. So now you check it. BC is a candidate key or not. That means B and C, they together any part of the BC, that means B alone or C alone, can determine all the attributes or not. If B alone is determining all the attributes, then then this will not be a candidate key. If B and C cannot determine all the attributes, then it is candidate key. So C already we are having, C determines only C. So B we can check here whether B can be determined whether B can determine all other attributes or not. So check it. B itself, it is there. B. Then B can determine which attribute? Again, you see, B can determine A. So B can determine A. Whether A, B is A and B. Here it came. So A, B. Whether this can be determined, can determine any other attributes or not. B and A. No. Only B is not determining any other attributes, and A is not. See, alone A, again A is determining D. So you can find out here D. Okay. Now, is there any other attributes you can determine from this one? B, A, D, B, A, D. C we cannot determine from here. From A also we cannot determine. From B also we cannot determine. From C also, from C is not there. From D also we cannot determine. There is no possibility right here. So now you see B cannot determine all other attributes, all the attributes in our relation. So that means it is not a super key. That means BC is a candidate key. Understood? So now you can say here BC and AC are candidate key. Okay. Now we got our candidate keys. What are the candidate keys are there? Now what you have to do? Now you have to find out the prime attributes and non-prime attributes. It is very simple, right? If it is a prime attribute, means it is the part of the candidate key. So here in our example, the candidate key is AC and BC. That means prime attributes are A, B, and C, and non-prime attributes are D and E. So now we got our prime and non-prime attributes also. Now come to the normal forms. So now you have to know all the properties of normal forms, like for first normal form what it should be, second what it will be, for third what it will be. So by default the relation is in the first normal form. Actually, if the table is there, by default it comes in the first normal form. That means there should be only atomic value. atomic value is there, like that already we assume, or we do like that. Then for the second normal form, what do we have to check? We have to check whether it is a partial dependency is there or not. So see here, the relation is not in the second normal form because A derives D is a partial dependency. Okay, because we have to remove in second normal form there should not be any partial dependency. So we should check whether partial dependency is there or not. So in our this relation, so here A derives D, or say A, which is a subset of candidate key. AC is determining non-prime attributes D. AC, see A is determining D, and AC is determining D is not a prime attribute, right? So D is our non-prime attribute. And second normal form does not allow the partial dependence. That means here you see D can be determined by BC also, and only A can also determine, right? B and C, D can be determined by A also again. BC is determining D. So here A is determining D. So here is A is the subset of candidate key. A is our subset of candidate key, right? So AC is determining non-prime attribute. AC is determining non-prime attribute D. That means D is our non-prime attribute. That means if the candidate subset of candidate key is determining any non-prime attributes, then there should be a partial dependency, right? If there in the functional dependency that like subset of our candidate key is determining the non-prime attributes, then partial dependency is there. That means it is not in the second normal form. So if it is second normal form means it should not be in the, it should not, so like it should not have the partial dependency. So here partial dependency is there. So it is not in the second normal form. That means it is in the first normal form. If it is not second normal form, then it cannot go to the third normal form, right? If it is not in the second normal form, then it cannot, by default it is not able to go to the third normal form or higher, right? So here in this example the highest normal form is first normal form, right? And say another one example you can take, I think is it audible?
Yes, ma'am. Now it's audible.
Okay. So this is the normal form. So this question I have given you for normal form. This is over. So one example I just want to give you here. Say this is our like first normal. Say we have like this. This Venn diagram, you know, like if it is in the first normal, say first normal form, first normal form, first NF, second NF, third NF, BCNF, BCNF, like this. So it will go inside like fourth NF, four, and after that fifth, like this. It will. So that means if it is BCNF means, if it is BCNF means it should be in third, that means third, second, and first. And if it is third NF, that means it should be in second and fourth. But it is not. It may not be in the BCNF or 4NF. Understood? So, like say, it is India, or this one is our Asia, India, then state, say Assam, then maybe Guwahati, like that. So if say I will say that in India, then I may be in Assam or I may be in state, And if I say like in Assam, that means I may be in Guwahati or I may be any other place, any other district. But if I say that I'm in Guwahati, that means I'm in Assam, means I'm in India. So that first normal form, second, it goes like this, right? So you have to remember, if it is in first normal form, then the value should be atomic. Second normal form, that means it should be, there should not exist any partial dependency. Third normal form means that transitive dependency will be not there. And VCNM means the left hand side should be superkey, right? So in fourth, multi-valued is not there. Multi-valued like attribute dependency is not there. Then fifth, join will come. And in the sixth, that any other like constraint is there or not, like that you have to, right? But mainly you have to remember till BCNF. So I think till that only it is important also. So this is for today's class. So now, so I just want to check who are all present here today.